to lift the drill bit off the ground, and the motor then it got the command to start driving, but it had a high spike in torque and RPM. We could see that, and then it dropped off. So we had a loop implemented to prevent things like this, so that the Z-axis cannot drive when the motor is not running. But due to the small spike in torque and RPM, we exited the loop, and the Z-axis started driving, although the motor wasn't on. So we have fixed this now. We have done some other minor changes. We also decided not to use the controller. We're going to use a constant forward speed of 0.8 millimeters per second now, and or 50 millimeters per minute. And we will start from survey 4 in the trajectory. So we divided the trajectory in 15 surveys, and I think we will start now. Good.
Okay.
Ja.
Wir müssen noch Rock Zero triggern.
Rock Zero triggern, ja. Also jetzt erstmal Initiation. Okay. So, erstmal keine Sorge, alles gut.
Ja.
Achtung.
Rock Zero.
Wait a second. Okay. Okay. So we're currently doing the query. So in the initiation, we have first a query taking place, and IMU is labeled as missing, but we will try to restart it during the process, so this will be okay. Drill string is not on the robot. Okay, now we're searching for Rock Zero. Yeah, we're gonna trigger the Rock Zero by finger. You can apply 1 kilogram, and then the machine detects that it is. It's triggered. Hi. Okay. Good. Then we'll.
We didn't home.
We did home. Yes. We're yeah.
I think we have to start the Rock Zero.
Okay. Then let's do this again. Yeah.
Fahren wir?
No. Wir fahren nicht. Okay. So it's homing again. Homing is done. Tara all sensors, and now we're heading again for Rock Zero.
Get one of the portable cameras to show us the bit going into the hole. There you go, like that.
Good job, Ali. So you guys, whenever you think you can hold your finger, the BHA, or you can move the drill string a little bit up, and it will trigger the Rock Zero. But if you touch it, it will trigger it earlier. So
I put it down.
Okay.
Nicht den Finger irgendwo zwischenklemmen.
Yeah, the Rock Zero process is quite slow. Cannot bend the drill pipe, or cannot drive so fast. Whenever you think it's okay, Kanan.
Ich glaube, er braucht noch einen Moment. some stages in the ceremony. Yeah. Du das, Kanan?
Yeah.
Ja, mach mal, wir dürfen nicht zu tief bohren.
Yeah.
Mach mal.
Yes. Let's go. Okay. Nice. Rock 0 determined. Okay. Now put the stabilizer on.
Brauchen wir nicht mehr. Brauchen wir nicht mehr.
Yeah. So sorry. Right. Then the cover up. Wir brauchen den Stabilizer doch. Stabilizer dran. Ja. I'm you is okay.
You can check in. I don't know. The box going.
Everything is all right so far. So I will now tell the algorithm to with which survey to start. So we are starting with the fourth survey. That means the next survey will be in 4 centimeters after the pilot hole. So we will now have 9 centimeters through the pilot hole to drill, and then 4 centimeters till the first survey. Warum? Das gefällt mir. The switches for the pumps are on? Yeah?
Yeah.
Okay. Notaus ist frei? Ist frei? Okay. Nice. Okay, you ready? Good. Motors and pumps are about to turn on. Waiting for the driller command. Pumps are on. We have RPM. Motor is on. And now I give the final command to start the drilling process. So start drilling. Okay. We're drilling. Driving with constant forward moment at 10 centimeters now. Wait, where's the camera? Maybe you can have somewhat of a look over here. True vertical depth, 16 millimeters now. Still drilling. Okay, survey. Yeah. Pumps on, motor on. Okay, first survey. Motor has RPM and we're drilling again.
Wir fahren während des Servers und fahren konstant immer noch nach unten, Alter. Wir sind immer noch bei 6 Zentimeter. 6 Zentimeter, dass wir nach unten gefahren sind. Also, gerade nicht mehr, aber wir heben ja noch das Survey. Da ist. Nee.
Wait.
genau gucken, wer ein Survey ist, ob das Ding immer noch jetzt bei 8 mm, das 8 cm sorry. Kommt jemand gleich bitte mal raus. Erik, ab jetzt stabil.
Danke. We got the first data point from the IMU.
9 cm.
Okay, next survey. Yeah, data from the IMU. Second data point.
Sachen runter.
Wait.
Wir fahren während der
Halt.
Kann nicht jemand Survey machen?
Okay.
Der Survey macht. Der die Drillbit stoppt.
It's okay. It's okay. It's okay. I can control it.
Ab jetzt stabil, stabil. 125. 30. Und das 40. Wir fahren hoch. Wir fahren runter.
Sachen runter, weiter.
Du musst hoch. Hoch.
Okay. So, I manually stopped the drill string from driving further down during the survey. I think I might have done a Vorzeichenfehler. Wie heißt das? Index error, but it's okay. I just resetting the survey value so that we are not driving down during the survey. Instead, we're driving up. So
60. Das war
wir müssen alles von vorne machen. I drive up. So.
Geht nicht. Manuell geht nicht.
Okay. You have the button. When you push up on the up button, you reset the Z-Achse. Weißt du? Dein Hoch-Button. Okay? Das kannst du machen. Ja? Also den manuellen Schalter. Einfach hochdrücken. Okay. Power out. Und das benutzen wir auch für die Survey. Ne? Versucht ihr oben mitzuhalten. Oder wir machen das. Okay, dann.
Ich fahre das einmal kurz raus.
Okay.
Ich nochmal das Problem.
Okay.
Ich ziehe es jetzt einmal hoch.
Ich kann nicht, der Motor ist aus.
Ja, haben wir den.
Manuell machen wir?
Delta ist 0?
Ja.
Okay. If you release it, yeah.
Scheiße.
From the state machine,
Delta.
I turn it off, okay. But then okay, yeah, I turn it off. Alles klar. State machine is out. Drück nochmal auf den Hochfahrtaste. Okay, jetzt fahr hoch. Oh. Okay, it seems like that the. Okay. Up. Let's flush the hole, and I turn the pumps off now. Okay. Yeah. Give me 1 minute, and we will restart. Yeah. 2. 10. Okay. Wolfgang, ich mache jetzt die Drill-Befehle nur mit 10 Steps, mit 10 Millimetern oder vielleicht sogar nur mit 1 Millimeter. 1 Millimeter. Okay. 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 Alles klar. Restart. Wait a second. Let's take the last positions from the survey. Ja, das Taran wir gleich. I'm just gonna take the last measurements that we have done. So we have measured 4 positions. I'm copying them because they will be reset when the program started again. Okay. Same process again. Ja. Gleiches Spiel. Wir fahren jetzt aber, ja, das ist das Problem, jetzt können wir nicht mehr, doch, kannst du den Bohrstrang noch anheben dann für Rock Zero? Okay. Initiation, start again. Setting all the set points.
Direkt bei die Kamera.
So, we start homing. Ist der Not ausgezogen? Ja, alles gut, wir fahren. We are homing. Search for Rock Zero.
So have you pulled back to the surface? I can't see the top of the rock.
Yeah, we pulled back to the surface. Ali, can you? Yeah.
Okay.
So we, since we have drilled a hole, we try to simulate the rock zero to still follow the trajectory. Otherwise, it would have a wrong reference point. So Kanan is going to push the drill string a little bit up to trigger the load, and from there we will start drilling again, now with less of and forward movement for each iteration, in order to not accumulate too much steps in the controller, because we just saw in the log that it had accumulated a lot of steps, so it was not able to execute how can I say, to drive that steps in one iteration before the next message was sent with more steps. So hopefully this will run now, but the good thing is we measured 4, so we have data from 4 surveys, and we'll interpret them after we're finished. Rock Zero is now determined. Motor and pumps are about to turn on. We have RPM. I'm now going to start drilling again. Hast du das updaten? No RPM. Okay. Do we have RPM now? Oh. No.
Auf jeden Fall. Dann geht es noch mit das Aufsteigen. Das ist.
Okay, wait a second. Current supply on.
Das ist das 24er drauf wieder, nicht das 48er.
24er. Ist die Z-Achse in Error? Ich mache beide aus. Both power supplies are off and now back on.
Das immer noch aus. Der Victor dreht immer noch. Der Victor dreht immer noch vom 48er.
Hard reset of the machine.
Raus.
Ja.
Also die Anlage aus, ne? Oder?
Yes.
Ja.
Okay. Let's try the following. Okay. Okay.
Yes, ja.
Turn back on.
Gedanken jetzt, ja.
Z-axis driving?
Ist
Okay.
oben.
So. Yes. Motor is not responding, but
Motor ist aus bei mir. Ja. Das ist aus. Der Motor.
Wolfgang, we lost the motor module. A hard reset of the machine with the switch. Main switch. So Broker laufen?
Ja. Nee, es wird auch. Es ist von selber aus.
Okay, machen wir mal an.
Oh, fuck, das ist
Ah ja. Ja, gesagt.
Rotary Table.
Rotary table is okay.
Ist unplugged.
Motor ist immer noch aus. Ein Abwählen sogar. Auf dem Tod.
Wolfgang, wie sieht der CAN-Bus aus? Okay. So, now the drilling starts. War kein Vorzeigefehler. Der Befehl mit dem Clear funktioniert nicht.
Das wird nochmal passieren.
Das wird nicht passieren. Ich habe jetzt einen Schritt gemacht. Wir finden das jetzt raus. Warte. Wolfgang, manuellen Button einmal drücken. Jetzt. Manuellen Button einmal hochdrücken. Delta resetten. Ganz kurz. Nice. Nochmal. Nochmal. Okay. Okay. Okay.
Jetzt mit oder ohne Service?
Mit Service.
Das ist übel. Haben wir das gleiche Problem nochmal?
Ja, alles gut.
Sicher.
Ja.
Was hast du geändert?
Es war kein Vorzeichenfehler, wir sind hochgefahren. Es ist nur, dass wir zu viele Schritte aufakkumuliert haben und die Z-Achse das fertig fahren wollte.
Der hatte immer runter, hoch, aber mehr runter.
Jetzt,
Ja, aber das funktioniert dann nicht so gut. So,
wie können wir das empfehlen?
now we have the transition to survey.
Kann man das manuell kreieren zwischendurch auf dem Monitor?
Warte.
Das ist 120. Wie fast da?
Wollen wir weiter?
Jetzt 130. Ja. Also 25 zurück. Wir haben das kleine Filterfläche gemacht.
Ja, ich weiß. Lass mich hier kurz arbeiten.
Ja, der nimmt ab.
Was?
Der Rotator nimmt ab.
Wieder rotiert.
Nimmt ab.
Ah. Lass ihn mal machen. Ist okay. The IMU is not responding. Wolfgang, IMU is. So we can do the following. We can drill through the rock and activate pads. So we can look in the trajectory that we drilled, activate the pads manually, and drive with the constant forward movement. Okay, IMU is not responding. Okay. Okay. Driving a little bit up. So unfortunately, yeah, IMU is not responding. We have done 4 surveys. We're now logging them, and then we will drill the hole faster with a manual input for the steering wings. So we'll do this now. Jungs, kommt ihr kurz her, dann gucken wir uns das an.
Okay, go ahead.
So let's take this away. Ich kann das jetzt nicht mehr öffnen. Wo ist denn das?
Das ist drüben.
Okay. Hier? Das sind hier. Close this, close this. Oh. Backt das jetzt? Okay, ich krieg das nicht.
Was?
Ich habe gerade hier, mein Python geht nicht auf.
Scheiße.
Eine Sekunde. Hallo, weißt du?
Ich stimme die ab. Ich weiß ja. Okay.
Ich bin komplett am Laggen.
Ich. Wollen wir den Rechner mal starten, oder?
Okay. Okay, now we can do this. It's a lot of processing for my computer since 1,000 things are running at the same time, but here, there we have it. This is the plan, and let's hope that the measured data makes somewhat sense. I see that we have a slight deviation. Okay, let's see. This fits in. Open. Steering flow. Yeah, here. Okay.
X.
How is the data format? What is it expecting? Azimuth inclination. The same, right? Oh my.
Die Komma muss weg.
Ja?
Ja, Beschleuniger.
Mm,
Verlaufen.
position plan.
Das ist jetzt kein Element, das ist ein Objekt.
Ja, ich weiß. Ich überlege gerade. Hast du jetzt eine Ahnung, wie wir das Position planen? Wieso erkennt er das hier oben und hier nicht mehr?
Exposition klar, GeoX. GeoX. Okay, kann das sein, dass das eine groß und das kleine andere klein geschrieben ist?
Dann mal gucken.
Komm mal runter.
Das ist das, was läuft. Ah, die Survey Number. Die ist groß geschrieben. Aber das ist eigentlich egal.
Nee.
Das ist nicht egal. Ja, das sind ja ein paar Punkte.
Das ist zu viel.
Hm?
Also,
Kannst du?
das.
Was? Das war's schon, das war's schon.
Alles was? Zu viel. Oh Gott. It's switch to X. Torf.
When you get a chance, tell us what's going on.
Yeah, we're trying to see the plan trajectory. We try to implement it.
Das ist eine Person klein geschrieben.
Nein, das ist nicht.
Wie hast du großen Plan?
Nur groß.
Das ist klar, alles groß.
Next survey target ist das.
Ist okay. Position X minus focus position.
This worked before. It's only the format has changed. 1, Gänsefüßchen. Denkst du, dass das ein Gänsefüßchen sein muss?
Nee, spielt keine Rolle.
Spielt keine Rolle, ne?
Nee.
Line.
Kann man durch. Warum?
NP Array Position. NP Array Position X, Y, Z.
Du hast zweimal, also Array, Inhaber Array, hast du. Das ist richtig?
Nee, das soll nicht so sein.
Ja, dann gucken wir das nachher.
Okay, wir können das nachher machen. Ja, brauchen zu Ende. Also wir müssen nach vorne ablenken und ab. Okay, so we're gonna plot it later. We're gonna send it to you. What we're gonna do is we're gonna drill to 350. Okay, with the pads activated from behind, so that we get some inclination. And after 500, we will activate the front pad and steer downwards. Okay,
Yeah.
We're gonna do it manually. Sorry for having you wait so long, but this will now don't take any longer. Okay, we're gonna finish it fast. Okay.
They're going to fly.
No, this will work. This will work.
Yeah, finger crossed. Of course, ja.
Okay, Anlage ist an Strom.
Ja.
Okay, everything is done. Power on. Haben wir akkumulierte Schritte auf der Z-Achse? Das will ich wissen. Ja, haben wir nicht. Okay, so power is going on. Wolfgang, you tell me which wings to operate. Okay. Right now, now we have.
Das Level ist immer noch gedreht, das haben wir nicht korrigiert.
Look at the rotary table, guys. But it's okay. 1 und 3.
Die versucht auch jetzt zu drehen.
Ja.
Abdecken.
Ich weiß nicht. Abdecken? Rotary Table ist abgesteckt, richtig?
Ja.
Wieso? Ich versuche es jetzt zu drehen die ganze Zeit, aber ich schicke nichts. Okay. Following, we.
Vögel müssen wir jetzt betätigen.
Jetzt 1 und 3 betätigen, weil 2 vorne war.
1 und 3 war bei mir was? Ja, 1, 2, 3.
So, du musst jetzt 2 und 3 betätigen.
Okay.
Aber für uns war das immer 1 und 3.
Wie viel? 50?
Hast du jetzt gesehen? Ja, da kann das aber bei Ihnen.
Willst du kontrollieren? Also, wir wollen nicht nochmal kommen. Ich kontrolliere jetzt, bevor wir anfangen. Wenn wir die Leute wieder richtig sehen? Okay.
Lass uns jetzt fahren.
Die gehen West bei.
Also, Z-Achse up. We're gonna have a look. Also, first power on, and then we're gonna have a look onto the.
Setz mal den.
Okay. We're driving up. We're just gonna have a look onto the wings and the current position, and then we'll start.
Willst du das jetzt machen? Mit dem Rücken?
Nein, Kanan, oder?
Wo die 2 Schrauben abdrehen,
Welche 2 Schrauben?
also wir machen das ab. Jetzt müssen wir nicht in welche Richtung wir tun.
Okay.
Oder?
Aber wir können uns die BHA jetzt angucken und dann abschätzen. Das wird, jetzt haben wir keine Messung, keinen Algorithmus. Ne? Also lassen wir das jetzt so, wir schätzen das jetzt ab. Ihr sagt mir, welche Flügel. Ich aktiviere die einmal, einen nach dem anderen. Ihr sagt mir, was das ist.
Eben haben wir nur 2.
Eben haben wir nur 2 aktiviert. Ich notiere mir das hier, welcher was ist. Nach vorne.
Nach vorne.
Okay.
Können wir das manuell machen?
Ja, manuell könnt ihr auch machen.
Wir können
Könnt ihr auch machen. Ja. Ich fahre jetzt Flügel 1 bei mir, okay? Ja. Noch nicht? Ah, ich dachte, die VHA ist schon draußen.
Nee, das ist nach rechts. Kannst du nochmal die Flügel rum?
So, ich fahre jetzt Flügel 1, Homing. Okay, also jetzt Flügel 1 raus. 30. 40. Welcher ist Flügel 1?
Das ist der
Der hintere. Also ihr sagt mir jetzt, welche Flügel ich aktivieren soll, okay? Das ist Flügel 2 bei mir. Flügel 1 ist das, was gerade ausgefahren ist. Flügel 2 fährt jetzt aus.
Das ist vorne.
Das ist vorne. Flügel 2 wollen wir nicht. Okay. Flügel 1 ist dann die 3. Das heißt, wir wollen jetzt Flügel 1 und Flügel 3, richtig?
Ja, aber jetzt ist nicht richtig.
Also auf 50, richtig?
Ja. War jetzt nicht richtig zentriert.
Das macht nichts.
Mach mal,
Home. Und dann fahren wir runter.
auf 60.
3,
1 auf 50.
okay. 3 auf 60, 1 auf 50. Okay. Ich home, ich fahre die Flügel jetzt ein. So, retract the wings. Again, pumps on. Power on. Motor on. Yeah, it's okay. It's okay. Noch nicht. Motor is not on. Speed, how much speed? 60. 60 millimeter per minute. Yeah. Motor on, and then we first 30 until we hit the ground, and then we will increase it. Okay. Oh, guys, drive down a little bit. First down drive. Das noch weiter, noch weiter. Okay. Ja, das ist hier schon. Okay, motor is on. We drive now with 30 millimeters per minute to rock 0, and then we will increase it and make it fast. We start retracting the wings as soon as we hit the rock. So I see the hook load, and as soon as I notice a spike, I will retract the wings. Wing 1 by 50, wing 2 by 60. 320. Wing 20, wing 1 50, wing 3 60. Von meine Wings. Okay, so we're if you didn't heard it, we're steering now manually, and I'm gonna say when we activate the bits, the wings.
Do you have any signals from the IMU?
I will ping it as soon as we drive the wings out.
Okay.
I'm just trying to focus now to that we have a good touchdown. Fahren wir? Okay, hook load? No, sorry. Wrong. Hast du dir gemerkt, wie tief wir waren, als wir unten waren? 200? Okay. Okay. So 5 centimeters left till touchdown.
Der Harry war das in einem gesetzt. Der Harry war das dann hat das in 1 und der war das in 2a, das war die 3a. Er macht das nicht so. Das ist nicht so, ja. Das Gesetz.
Rolle haben wir Cuttings? Cuttings? Yes? Okay, touchdown. Touchdown. We have hook load. We are driving. Okay, extract the wings.
Wirklich bei uns, wegen sie bei uns nummeriert sind. Du kannst das
1, 2, 3. 1 ist nach vorne, 2, 3.
Richtig. So, bei 3, also hier hinten wollen wir 60 und da 50.
3, 60?
Ja.
Und
1,50. 1,50. Ja.
1,50. Okay. Set wing position. Okay. The wings are driving out. Torque is decreasing rapidly. Wings are retracting. Okay, we're drilling again. So I drive 5 centimeters per input with a constant speed. So now we have driven the first 5 centimeters with 50 millimeter per minute. I go up to 60 millimeters per minute and drive down. The wings are still set, and as soon as we reach TVD 350 or 400.
Yeah.
Yeah, as soon as we reach TVD 400, we will switch the pads in order to achieve this S-type shape. I will frequently put measurements in.
What's the current depth?
The current depth is 309 millimeter.
Haben wir das getan?
Yes. So I would go ahead and try to reach the IMU. Okay. Yeah, unfortunately, I cannot. It seems like we're not getting data from the IMU. Yeah, I'm sorry about that. But the drilling process is going good so far. 350 now reached. We're deviating definitely.
Bei der ist 6 und 1.
Ja, deswegen sag ich doch.
Ja, ich habe dir die Zahlen bei uns gegeben.
Ich habe doch gesagt 1, 2, 3. Wolfgang.
1, 2, 3. Das ist aber so, wie wir es da haben. Das ist nicht versetzt.
Ah, ich habe das hier getaucht.
Okay.
Yeah. Should we? So we are now about to reach 400. Should we drill further till 450 with the same direction? And on 450, we would then have 10 centimeters for the dip. Okay? Okay.
400 anfangen.
Wir sind jetzt bei 400.
Ja, jetzt anfangen.
420. 420. Okay, okay. Yeah, we are having actually quite high hook load, no?
How much? 200. Oh, 500. Was ich wollte 600, da liegt die weit. Also ist jetzt bei 600.
Wait. Ja?
Mach jetzt nur 50 Millimeter pro Minute.
Okay. Probably the hook load is drifting, probably.
Aber lieber auf die sichere Seite.
Wir fahren. Ist doch gut, oder? Motor läuft.
Alex Flugel,
Okay. Wings change. Wing 2 auf 60.
Ja, in welche Richtung ist nach hinten?
Ja.
Nee, ich denke jetzt erstmal weiter und dann wieder nach hinten.
Wir sind jetzt so, jetzt ist mal so.
Ja.
Wo ist
Jetzt
jetzt?
die Hookload bei 400.
Die Hookload macht, was sie will. Das ist schon in Ordnung.
Wo ist die Kurve? Was ist die?
Nein, ja, also nee, jetzt gerade nicht mehr. Die
Okay.
Kurve war so. Jetzt sind wir an dem Punkt. Jetzt sind wir runter. Das heißt, Flügel 2 ausschlagen, ne?
Wird sogar. War einfach auf 100%.
Auf 100%.
Ja.
100%. 100, echt jetzt?
Ja.
So wing 2 with 100%. Now at 470 millimeter. 13 centimeters to go. Ich habe gelenkt. Okay, so we just got the feedback that the wings are deployed, and my colleagues, it seems like they see some bending in the pipe, or maybe they think about it. Yeah. Yes.
Erstmal so und jetzt machen wir das S.
So 12 centimeters remaining. We are driving 10, and we will leave 1 centimeter for clearance. Okay. Okay. 10 centimeters left. Nine centimeters left. So I think what we are observing, if somebody has a Ali, come here. Show them this plot. So we see that the hook load has an unreasonably high value, but the torque doesn't correlate to it anymore. So it's just an assumption, but I think if we have deviated, it could be that the drill pipe is pushing against the rock, right, upwards. And that's why we're seeing such a high hook load value. But the torque is constant. Okay, we're driving the last 8 centimeters. I just interrupted it.
How much torque do we have?
We have, you can see it over here, somewhat. Z-Achse? Okay. No problem, no problem. Einmal kurz Power Supply on off. Ja, warte kurz. Ich will nur, nimm mal den Taster in die Hand und drück die ganze Zeit hoch, okay? Taster. Hochdrücken. Nein. Den Button zum Hochdrücken, damit die.
Ja, der hat schon.
Ah, okay, gut. Nice. Sorry. It's so emotional. I swear. Good. Now we can start the Z-axis motor got into an error state. Too high. Too high of an hook load. So I reduce the forward movement, and we'll start the motor again. Motor on. Motor has torque. We drive down, and I drive 7 centimeters now. And hopefully we stop before drilling through our rock sample receiver.
Zweite Flügel.
So
Nicht gerade.
wings are still
Eigentlich ein bisschen von dem Flügel, die Richtung. Damit wir
out. Okay. 77 millimeters remaining. I would say the only thing that is constant throughout the whole drilling process was pump pressure and flow rate. So that's not bad. Yeah, you can see here the rotary table is still trying to move, but we are plugged in. Yeah. 6 centimeter.
Okay. Aber ist das kalibriert, richtig?
Okay. Error again.
Etwas langsamer.
Yeah, we will drive a little bit slower. I hope that we deviated. This could be a good sign.
Wolfgang. Oh. Delta weg.
Delta weg. Okay, out and back on. Motor on.
Motor is on. Drill motor.
Yeah, we have torque. We have torque. Okay, now drive down again.
We have now a torque of about
6 amps. That's 3 newton meters.
3 Newton meter.
I reduced the forward velocity or the rate of penetration because the Z-axis motor is not capable of handling the downward movement. Actually, even though we don't have a lot of torque. Yeah. So
That's maybe because of the tilted bore.
yeah, that may be because of the tilted pipe. Yes. So now we're dangerously close. I hope that we have done everything right for the
Remaining 4 centimeters.
yeah. I stopped at 2 centimeters.
Close the wings when you go up.
Wings driving inwards. We drive up. Foaming. Okay, we drive up. I'm gonna do it a little bit fast. Why?
Wir bohren mehr rein. Wir bohren mehr. Bitte.
It's okay.
Noch besser mit weniger ATM, wenn du kannst.
Wir fahren hoch.
Ja, ich weiß. ATM können wir nicht aus.
Hä? Wir gehen gerade hoch.
Ja, aber steht dabei rotieren. Ja, okay.
Yeah, we still have rotation. The hook load decreased by 600 from one moment to the other. We have formed the wings, yes. Ah, okay, this could maybe be the reason.
Wir ziehen an der Frage und wir haben immer noch Druckkraft von 150.
Die Flügel sind in. Ich kann
Ja,
nichts
ich
mehr machen.
meine, das ist auf jeden Fall gedrückt.
Definitely, yeah. Yeah, we're pulling the pipe and we still have some friction keeping it down. Ja.
Gott, das wird zu schnell. Ist ja egal. Nicht
Bis wir noch Flügel haben, haben wir noch.
Das an dem Mann. Weißt du?
Ich kann auch mehr Speed machen. Was wollt ihr denn?
Also lass es so. Vielleicht 20 mehr.
Ich habe 200 gemacht.
200 Watt.
Are we coming out of hole? We still have over 30 centimeters to go, guys. It's is the hole clean?
Yeah, clean. But when you get to the top, it's fine.
Yeah, it's okay. I will cut rotation at like 5 centimeters before we exit. Sorry. Oh, sorry. It's you need something physical to control the robot. It's something digital is not so nice. A real button would be not bad.
We need a simulation chair.
Motor is off. Pumps are going off. Okay. We're coming out slowly. Yeah, let's let it hit the end stop. IMU is still blinking.
Still blinking.
Yeah, we probably need to reset it. It did this a couple of times before.
Yeah.
So after you ping it 6 to 7 times,
Open and close when you're out of the hole, open and close the wings a few times so we can watch it operate. Once you're out of the well.
The wings?
We are out of the well. Now we can remove the stabilizer.
Yeah.
So maybe remove the cover.
Okay.
So and then we will do this definitely.
Let us watch it with the camera also.
So
they're just removing the cover right now.
What I'm thinking about, maybe as soon as we leave to Germany, we will make the IMU run again and go through the hole and just measure on different points and rebuild the German trajectory, and then we will just send it to you. Or maybe we will cut open the stone.
Yeah,
right. Better.
Sounds good. Either way.
Right.
When there's no forces on the Bowden rods or wires, can you do the wings collapse so you can pull out of the hole without and make
yes,
just by pulling out?
As long as the motor is not powered on the top, the pulley, the wings can be pushed in by the wall. So there's no how do you say, blocking force when.
Right. Okay, got it.
So.
Yeah, just operate them. Let us see it work.
Okay, good. 24 volts are on. Set wing position to 100% on all 3 sides. 100%. Okay.
Okay.
Retract. It looks cool, right?
Exactly.
Good. Yeah.
We have to pump out the water of the hole. Maybe we could see that it's tilted.
Yeah. Do we have we have the mobile pump? Water pump. I will bring it, and if we have a hose that we connect, we can just suck the water out and have a look into the hole.
Meanwhile, I will ask a question of the team from UMONS. Can you summarize what you did today and what you learned?
Yeah. Okay. So here is Martin. Okay. What did we learn today? Well, I would say that yeah, we have a good perspective, outside perspective, yours and the one of the Germans. Yeah, we could see their dispositive. We could see their their way of doing things, their programmation, they maybe also their mistakes. Yes, your feedback was really interesting. Also really interesting because they were a perspective that we didn't really see. We didn't really anticipate. I think about especially if we increase rotation speed for the future, the behavior of the drill pipe. There is a lot of aspect that we need to rethink and to correct. But beyond the fact that we have beyond the fact that we did something functional, there is also a lot of aspects to improve. And, yeah, so
You know, with this competition, you will never finish, right? There will always be something else you want to do next year, right?
especially if it's the first time you participate. But
even if it's the 10th time, you're still going to be saying, I need to do something else.
And the Germans, we talked to them. They are friendly, and they explained us how it's work, and they told us exactly the same the same thing, that you always have something to add to your dispositive and to your rig, and well, that's a
So you have
interesting aspect of this competition, because you can always the way to improve and what.
So with engineering, there's never a right answer. There's just a better answer. And so you now instead of just making calculations, you have to build something. And it has to be waterproof, and it has to be able to handle vibrations and lots of different things. And it has to be done on a schedule. So you constantly have to make trade-offs and make priorities. So, you know, and to meet the requirements of you're going to do this test at the end of, at this date, you have to make priorities and stick with those priorities. And so you learn more than just calculations.
Wait, you can't hear you. Wait. Okay, it's okay. So I'm so sorry, but yeah, they're doing something.
Something like a little bit bigger.
Okay, you can continue.
Please. And then it comes itself up.
So it's not just an engineering exercise, it's an exercise in project. It's an exercise in teamwork. You need to look at the makeup of your team for next year. And as you get into more automation, you may need people who are familiar with automation. So you may want some controls personnel, people who are very familiar with control systems and feedback systems and sensors, as well as the mechanical aspect. And we'll try to introduce you to some people that can help you with the drilling problems.
Yeah.
Because as you get more and more into the automation, You have to detect the problem and then act to correct the problem. It's not easy. It's really hard. And this is a very tough, very difficult competition.
Well, I guess so. Yes, yes. We were quite limited by our skills as mechanical engineers, but we have in our faculty we have several services and mining engineering and electrical engineering services helped us, and it's not only a competition, it's also a teamwork.
Yes,
Is the word?
very much so.
The words.
Very much so. And so what we do here is we give you the ability to go to the workforce and say, I have been working in a team and I have worked in a project and I have produced these results. So when you're looking for a job, you have some very special skills that some of your other students don't have. Some of your peers don't have that. So I think that's one of the things you might want to consider. I would ask you to, sit down over the next week or two and think about, okay, what do we really need next, and let us know. Right? Let us know if you need help, and we'll try to find a way to get you that help.
That's really kind. Yeah, I will do that. We will meet again and make meeting with our team and to debrief to debrief this day and to find to find solutions to find the issues and
Okay.
all aspect to improve, might be technical or outside or outside the drilling process.
And it may be financial. Okay. Also look at that.
Yeah.
Right. As you said before, you had people help you because of delivery. They're concerned with when these materials can be delivered. And again, that's a real world problem that all of us have to deal with.
Yes, I'm really well I really know that now. Yeah. Because it was our main problem. Delivery time is limited us in our choices. We have always chosen elements, might be motors or something or everything, but these elements needed to fit with our sizing, not to be over or undersized. So that's limited a lot our
But I just want to warn you, when you start rotating faster, you'll have vibrations, and there'll be a lot of issues with vibrations, trying to get seals to work, trying to get bearings to work.
Yes.
Okay? A lot of times that top drive motor does not have a thrust bearing in it.
Well,
since when you're pushing weight on that shaft of that motor, so there's going to be an upward force on that shaft that a lot of people don't know is there. Yeah. I worked on a drilling rig that had Varco's top drive serial number 1. And it didn't have a thrust bearing in it. And when the drill pipe parted, everything came out the top of that motor until they ended up changing the design of the motor. Okay. So you're going to have the same kind of problems, and it's better for you to see it than for us to say it, because once you see it, then you learn it. Okay.
Yeah, I understand. Yeah, security has always been the the main our priority. The security has always been a priority for us. Yeah, the safety, yeah, have always been a priority for us. But in the way that we see the rig, well, we didn't anticipate what the rig would look like in several years, and that's security aspects. But yes, we will. It is of course the first thing we are going to check. We are going to discuss when we debrief with the team. Is that main aspect.
We will talk with the people in the industry to see if we can get you an invitation to visit a working drilling rig.
Okay.
That might help also.
You have my email. You can send every information.
Right.
That we. Okay.
Okay. Well, I'm telling you, you guys did the best I've ever seen in a first year intern. You did a great job.
Thank you very much. It's I really appreciate it. Yeah, we're looking for it.
Okay.
Thank you.
Shashi, Enrique, judges, do you have anything to add?
Yes, maybe just one comment. Definitely echo Fred's comments, but I want to add one more thing. I think as a team, it was really great to see you guys drill the first time. I think hopefully during the process of last 1 year, you learned a lot, right? How to prioritize, what to focus on to get this rig working. And looking at the end result, looks like you made the right choices in terms of what do we need to focus on to get a working rig. So really good to see that. Looking forward to having you engage with Drillbotics and continue on this journey.
Well, we will. Thank you.
I equally congratulations from the other judges. You guys did a fantastic job for a first year rig. I mean, just the fact that it's working and you have it automated, that in itself is a complete success from my part. And yeah, you were way better than a lot of first year teams that we had in the past. I also wanted to bring out the fact that you actually tested to get your measurements, to get your motor specifications. You actually did test, the amount of torque that you were actually going to have on sandstone, and engineered your way around that instead of just relying on theoretical calculations or textbooks examples. And that itself is really commendable too. So congratulations, guys, and welcome. And I look forward to what you gonna do next year. Thank you, guys.
Yeah. We'll of course continue the competition next year, and it won't be us. Student will change, but be sure we will transmit by reports and feedback of experience to the next ones, and to tell them what to focus on, priority and how exciting this competition is. So yeah, thank you. I really appreciate the fact that you recognize our work, and yeah, I'm really glad. Thank you.
Same, but I mean, you're still. So that's my specialty is sort of. So we have now there's counter accelerometer bias. Under observing our algorithm corrects the. So you'll still have uncertainty associated with accelerometer. Obviously, it's going to be much smaller than the gyro. You guys did a great job creating our own for calibration.
Bon, vous avez une machine qui marche, qui a des changements théoriques.
Que dit-il?
Maintenant, on va faire un bon rapport, vous allez nous mettre 20 en note.
Moi, je mets pas.
Somebody get the German team on this line so we can talk to them.
There's somebody from the German team.
Oh, yes.
Your turn.
Yeah.
Yeah, no, just you can stay there if you want.
Stay there.
Yes.
Okay.
Yes, the camera is
So.
for you. You can check on the screen.
Okay. Now I see.
Is it fine like this?
Yes.
So I just wanted to say I'm really glad to see that you made changes to the BHA. Number one, that you shortened it enough that you could actually build angle. We had talked about a maximum of 15 degrees, and that's probably too much for anybody to reach. So as we go forward next year, for steering next year, we would cut that down to somewhere around 8 to 10 degrees, somewhere in that range, and maybe even lower. You're still having some trouble with your automation sequences, so find the right people for next year to help you with that. The rig is robust, and your bit design is fantastic. Your ROP is off the charts. It's really good. So that the only thing is get a good control system with stability that can be automated. I have a question. When did you last change the software?
Actually,
Was that today?
That's the big question.
it hurts so much to tell, but we didn't change it a long time ago, but we didn't have a chance yet to really test it out. And actually, the control algorithm that failed today was part of my bachelor thesis, and I went through the series. It's not finished yet, yeah. But I made a code, and as I went through the steering algorithm, I still thought it was applicable. I did some changes to make the calculations easier and more reliable, but the main concept remained the same. Yeah. But we will see if we will figure something out for next year, something new.
Yeah, we just learned in our business that if you make a change at the last minute, it's usually the wrong change. Okay, so plan ahead and test it, and if it's working a little bit, that's better than not working at all. So keep that in mind as you go, because the other people on this phone call, the other judges, they've all been there. And like I put in the chat, one of the things Benoit talked about was the demonstration effect. So, whenever you're doing a demo for your customer or your judges, something breaks, always. All right. So plan for it and be prepared as best you can. The improvements in the BHA, the way you've shifted from hydraulics to the push-pull lines of the Bowden system, that's much better. So I think the wings were very successful. I would like to see you do a post-mortem on the IMU and find out what failed. And maybe it's sealing, maybe it's something else, but let us know. I think that your BHA looks good. Having your separate magnetic field on there has been very successful. You're the only team that's done that. They'll probably copy you in the future, and so that means that you're doing a good job if they start to copy you. I'm impressed. I heard somebody say they want a joystick added to it so they can run it manually at some point in time. So that's not a bad idea. That's a good plan. I mentioned to you also, if you're going to be putting weight on the bit, make sure there's a bearing in the top of that drive motor. Anything that's for you call it a rotary table, okay? Your rotary drive. There's going to be an upward force because you're putting weight on the bit through that pipe. So make sure it can handle that. You got the wings where they collapse safely. That's great. I think that was a good point. But next year, teach us more about how you actually compute the well plan when we give you the targets. You know, are you intentionally trying to hit all of them, or will you sometimes slightly miss one? Recognize you don't have to hit dead center in the target. You have to hit that circle. So you have some choices and trade-offs that you can make. I think that the two judges that you have there with Tim and Matt can help you with that just by aiming you at some of the right resources that are publicly available right now. No, I'm looking back at my notes, and I mean, most things I like are pretty darn good. You've understood what you need to do to get the RPM up so that you can drill with that a little bit. And noise, electrical noise, be careful. Okay. Careful, there's ways to shield cables that might help you. So you can look that up. What else is on my list? That's about all I've got, I think. Shashi, Enrique, Tim, Matt, comments?
No,
Yeah, I'd like.
Go ahead.
I would just like to say this is my first time being involved on the pseudo judging side on this competition. It was really cool seeing both the teams do the drilling. I was really impressed with the magnetic field that you guys set up manually to combat not having to orient to like magnetic north, you know, in the testing area. I thought that was really cool and creative to, you know, make it so that your magnetometers were where you wanted to be and you could orient the sandstone to like your own magnetic north. I thought that was really cool. I did have a, do you know what kind of magnetic field's coming off of that coil as far as like nanoteslas?
We measured it, I think, Erdmagnetfeld ist 10 hoch minus 9, ne? Und wir haben gesagt 10 hoch minus 4.
So it's, yeah.
10 hoch minus 4 Tesla, ne?
3, I think.
10 hoch minus 3 Tesla, right? 10 hoch minus 3 Tesla. So
10 to the power of my.
yeah,
It's
10
about
to, yeah.
million times stronger.
Yeah.
Okay, yeah, I think that's cool. I would just make sure that to look at your magnetometers that you're using and make sure that you're not causing any saturation there, because that could affect how the azimuths are being calculated. But without doing any math, you know, in my head or whatever, I'm sure you guys have looked at that. Just maybe a pointer for future. But great job, and it was really cool seeing you guys do the project.
Thank you very much.
Thanks.
I was extremely impressed by this, by you and the team. Congratulations! I think you're the most advanced rigs I've seen so far, both in terms of software, hardware development, the circuit design. You know, just having your magnetic field in there. And if I had to speculate why the downhole sensor failed, it's perhaps you were using a digital communication protocol that is very susceptible to noise. So you just need to miss 1 0 1 1, and then everything goes around. So congratulations, guys, and you know. Also, I want to commend you on the report. The report is top notch. The quality is great. So whoever wrote that report, congratulations on technical writing and the way you presented all the information there. I think it's very thorough and very well thought out.
Thank you very much. Should we also say some words? How did you like the experience, this robotics here? I mean, not the last 3 weeks, but everything before that.
The last month.
The last month, okay. Yeah. I think I speak for every one of us if I say that we had a lot of fun, and we enjoyed building the machine. I mean, no one of us. We stayed long times in the lab, but it didn't felt like we're forced to be working. It was like something that we did with a lot of fun, right?
Passion.
And passion, yeah, definitely.
Yeah. It was challenging, stressful, but we learned a lot. That's the main goal. Right. And it made a lot of fun.
Yeah. Eric, welcome. Thank you very much for supporting us during this year. I hope next year will be you will be also supporting us, and the team will stay together.
Be great, yes. Maybe you can take some more students on.
Yeah, definitely. We will try to get some more students to work with us into the robotics team. We always try to find new people to join us, and I would also like take this opportunity to thank our donors, all the people that helped us building this drilling rig, even if they donated money or if they donated hardware. We are very grateful for that, and we hope we can give something back to them. And I would just call them out. ETA Engineering. Oh no, where's the sign? Bring it here. Let's go.
It's there.
Yeah, that's the ETA Engineering, but there's some more. Yeah. ETA Engineering. This is the workshop in our institute. Micon Drilling. And thanks a lot for providing for manufacturing the nice drill bits. They work decent, so extremely good. And KCA Deutag, of course, and Baker Hughes. So thank you very much. And I think I have nothing more to say, right?
Thank you for University of Mons for having us.
Right, and thank you for the University of Mons.
Great hospital.
Definitely. And I think we have something now for them, right? We have it in the trunk.
Brought the present to us.
We bought a
From
present
Klaustadt.
from Kloster.
Yes, but it's the fridge.
I
which print?
understand. I think I understand.
Yeah. Okay. Okay. Good.
You guys go out and celebrate, but don't celebrate too hard so that you can get home safely. All right. Congratulations, everyone.
Thank you very much.
Thank you.
Cheers.
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 Bye bye. See you next year. Okay. Das ist fast wirklich. Ah.